Alright, so hello and welcome. I whispered today, or now, didn't really feel too good, only solving 2 problems today. I kind of spent a lot of time watching things on YouTube. I like to just listen to what other people have to say. And I also spend a lot of time, like when I eat, I go eat and watch something and just kind of hang out. But, alright, so this problem is remove invalid parentheses. And we'll take a look at that shortly. See what we can do here. So we use vectors and strings, huh? I've been listening to this song a lot lately. I think it's good. Okay, given a string S that contains parentheses and letters, remove the minimum number of invalid parentheses to make the string valid. Return all possible results. You may return the answer in any order. So, excuse me, so you can remove this parentheses to get you this one, or you can remove this parentheses to get you this one. So it's any minimum number. Oh, I see. I see. Excuse me, it contains parentheses and letters. Okay. Well, for the most part, we can ignore the letters, I think. I don't think it matters. Interesting. I'm not really sure. Can remove both parentheses. 25 characters. Okay, so this a strict brute force solution is not going to work. It's like so we need to have, say, there's some kind of optimization or at most 20 parentheses in S. Okay. Well, actually, 2 raised to 20. That's not too bad. A million. Actually, we could do a strict brute force solution. Just as long as it's exponential, just either have the parentheses or don't. So then go through all the possible solutions. Actually, that might be the way to do it. Just have to check whether each of those strings is, well, if you do that, I mean, that could be kind of expensive. 20 million? I think 20 million is, could be reasonable. Could be okay. What's an idea? Yeah, you can do I mean, it's one way of doing this. There's a few pieces here if we do it this way though, but one way that can be done is walk through all possibilities where you either have that parentheses are not present in the string, and then we could parse the string, checking whether they're valid parentheses. So we could have a subroutine that checks whether a string is a valid parentheses, and then we can have a routine that we either have or don't have that character in our. And actually, with the subroutine, we can make these vectors of booleans rather than or vectors of characters might be better, but instead of strings. And we just check the vector of characters. If it's a valid string or not. I think a vector of booleans is better, actually. Yeah, because you can, if we have that character included, we can find for that index what the character is in the string, and then check what to do, right? So we can have like a slightly modified parentheses check subroutine, and then we can go through all possibilities of whether or not we include a particular parentheses or not, and then at the end we can walk. I guess what you could do is just set all of each vector, just set all of the characters that are not, in order to generate the strings at the end, all the characters that are not parentheses, just always set them to true, so they'll be included in all the possible vectors that we have of booleans, and then each of those we can, and they don't have to be vectors, they can actually be arrays, because we'll know the size of the string. So they can just arrays of booleans, and then we can use that to, generate the strings that are expected in the return vector. Yeah, so every valid parentheses that exists, we can actually, we could do something kind of interesting where we have a minimum value, minimal value, and if we see a smaller minimal value string, then we can update that set to include just that value and dump the larger strings. And then if we see more of those of the same minimum, then we would update the return value there. So we can write a routine that updates, so we can get this minimum set relatively easily. So we would do, so we can we can loop through, and in fact we can use a depth first search even. Well, not necessarily depth first search, but yeah, we have a Boolean array that we modify, and then for each Boolean array we run our routine to check whether this is still a valid set of parentheses or not. I mean, it's brute force. It's on the more expensive side. I'm trying to think if there's a way to do this. Yeah, because we could just loop through all the bits. You can use some bitwise, what they call that? You can use some bit manipulation here to do this. I'm gonna do this. 20 million seems like a lot. Seems like it might TLE if we do this. Well, we could try it and see if it TLEs. If it TLEs, then we can think of something else. But this is gonna take a while if it doesn't work this way. So we could try this. And we can say, you can iterate through. Tricky thing here is we want to go through all the possibilities, but skip over the indices that have, over the bits that correspond to characters that aren't parentheses, opening or closing parentheses. How can we do this? So this is going to be exhaustive search, by the way. Oh, that's awkward. Otherwise, we could just add numbers all the way up, but I guess I want to skip certain bits. I might achieve that. Trying to think here. This is, by the way, one way of generating all of the possible combinations. That's more or less what we're looking for. We're going to loop through all of the possible combinations. Well, we could draw a map. We could just write a mapping from the bit to the correct character. Excuse me, so the bits will just be from left to right of the indices of the characters from left to right. So we can do something like this. Count number of non-alphabetical characters. Lowercase English letters, so yeah, parentheses, so we'll just say 4. So actually you want to have something like standard accumulate, no. Maybe you could do that, standard accumulate, int n, or m, or parens, we'll say. And we could just have I don't know, temp, I'm not sure what to call this. It's comparator. So the accumulation is going to be an integer total. And this is going to be a character. And we're going to convert this to an integer. C is not equal to opening parentheses or C is neither this parentheses or that parentheses. Or do it the other way around. C is this one or that one. And so you can say accumulate s begin, s end, 0 comparator. Okay, number of parentheses. And now we can say bool array of parens for int I equals 0, I is less than. So this isn't really, this is actually going to be an int map, parens map. That's going to be, this is a tricky thing, map each index from 0 to the associated now the question is we could map these directly to the characters, or we could map them to the indices in the array. The problem is think about this is challenging. So what am I trying to do here exactly? Well, I want to loop over all the numbers. So if I know how many parentheses I have, then I can loop over that many number of bits, and I can just loop over integers up to 1 less than 1 bit shifted over that many number of values. So from 0 to that whole bit section filled with ones, and just iterate, add 1 each time, and that'll loop through all the values. Now in each of those situations, and that'll give us all of the combinatorial sets that we need to work with, but the problem is that we want to then translate that to an actual string of characters, and there are some characters interspersed between these parentheses, and we want to just insert those in the right spots. The issue that we're going to run into is each of these bits corresponds to a certain character in so what I think I can do is I can recreate the string from some data structure that we have that does something with these parentheses by basically taking characters left to right through the string, and if the bit that we're currently looking at, if the index associated with that bit, if the index we're on is less than the bit that we're looking at, then we would take from the string. If we are on that bit, equal to that bit, then we're going to, whether depending on what, and the bit is mapped to an index. So at each step we can check our parentheses map. So bit to index, right? And this will take also an index, and we have to initialize this. So this bit will go to be associated with a certain index. We can get this value each time. And we could say, as if we're smaller than that, then we're going to take the characters from the string. If we're equal to this, then we're going to take, depending on the value of that bit, if it's true or false, we're going to either include or not include the associated character from the array, which would be an open or close in parentheses. And then we're going to update the bit index to another value. So we'll have two iterating values. And then we'll perform the same routine. So I is going to update and j is going to update. And then we'll say again, if I is equal to the bit to index value, if it's less than the bit to index value, then if it's equal, then we take the bit. If it's less, then we update these to the next ones, as mentioned. So each bit is going to map to a certain index, and we can say j start off at 0, and j is less than s.size. And what we're going to do is we're going to say while j is not equal to actually we can say, so if s of I equals this or that, either of the parentheses, then we're going to say bit to index of j is equal to I, and then increment j, and do it this way. And then I is going to go to the next spot, and so now we can have our bits. So each bit index will have an associated index in the string. Yeah. So this is kind of a peculiar way of doing this, but you can do it this way. And now we have process we'll have a check valid parentheses subroutine. We're going to have a number. So now this is a tricky thing. Given a particular integer, so we're going to return a Boolean. The subroutine. Call it a subset. Returns a Boolean. So this is going to use a stack. And we say, and actually I'm not sure if you even need a stack for this, quite frankly. Now the question is, these numbers, you really could understand them in any order, but I think we can go right to left for the bits. What's interesting also is that the parentheses are valid right to left as they are left to right, which is peculiar. Just thinking here. Should probably only allocate this stack once and just reuse it and empty it each time. Yeah, it's fine. It works. Just thinking here. We can go right to left. We're going to use bits to tell whether. Oh, so my question was, you don't necessarily need to use a stack. That's the thing. I think you just count the parentheses. That was something I learned recently. It's like, wait a minute, you don't even need a stack. You could just have a number. I don't think it's entirely necessary to. Yeah, I don't think it's entirely necessary to have a stack. It's just you add one to your count if you see an opening parentheses, and you subtract one from your count if you see closing parentheses. That's it. And if you, yeah, so starts off at 0, and we say 4. Now this is going to be peculiar. So I equals 1. I is 1, or x, we'll say b is 1. Alright, we'll say x is 1. Or, yeah, x is 1. And I be from 0 is less than parens, and we're going to increment I, and we're also going to update bit shift x1 to the left, right? And then we're going to say if subset of and x, right, if that's true, or if that's 1, at least 1, and s of I equals opening parentheses. So if this is the case, then we're in business. Otherwise, we don't do anything if this isn't set up. So we'll say const character C is equal to S of I. Say if C is equal to, well, there's only two possibilities after all. Well, yeah, if S is equal to, so this will be the opening parentheses on the right side, going right to left. And then we increment the count. Otherwise, we decrement the count. And we say if count is less than 0, and return false. Yeah. That's a little confusing. But after this for loop, count equals 0. So if you still have something in your stack, or if you've gone below 0, I mean, this really just terminates early. But no, it doesn't just terminate early. I mean, you could also, yeah, you would, if this is greater than 0, it would be false. So it's got to be equal to 0. I think that's all you need. How are we doing on time? 30 minutes? Yeah, okay. So that's all you really need. You're not going to overflow with only 20 elements. So we can check for valid parentheses. And that's all we need to do. So process subset of parentheses int ret, and we have some pre-processing steps beforehand. Hopefully this is fast enough. So we're going to say for int I equals 0, I is less than const upper int. That's going to be 1 bit shift to the left parens number of times. Excuse me, and we're actually going to be less than this value, so excuse me, 0 up to that, but not including that number. And we're going to say if valid parens of I, then we're going to update. Yep, index. This part is, this is when we want to convert back to, so this isn't S of I, by the way. This is bit to index S of that. So yeah, which the given bit will give, yeah, that'll, right, that's how we want to do it that way. And when we recreate the string, we're also going to use this mapping as well. So if it's a valid parentheses, then we want to say, now one question is the number of parentheses that we have. We don't actually know how many bits we've set to true. I guess we would need to count. That's awkward. Yeah, that is a little bit awkward, isn't it? It's called, there's a subroutine called pop count that you can use, but we're gonna write our own. Just bit count. Whoops. So we'll just say, also we know we're only counting how many bits we're going to count. It's very similar to this kind of routine here. Actually, what we can do, we can also just return a count. We could do these in tandem. Yeah, we can do it this way. Yeah. So we can set up our count here as well. Oh. Bit count is what we want. Yeah, this is going to be an interesting thing we do here. Int bit count. Start off at 0. Do it both spots. Yeah, and this is going to be a reference, so this value will be set here. So if we have valid parentheses, now we get the bit count with our routine. So we don't have to write our own bit count routine. So that gives us the number of parentheses that we have or don't have, and we can say constant n parens. It's going to be parens minus or current parens, total parens minus the bit count. So what's interesting about that is remove the minimum number. So the current parens, so removed, or parens, we'll say, remove parentheses is the difference, right? Because the bit count plus the removed parentheses is going to be equal to the total number of parentheses. So that's r parens. Now we say if r parens is less than min parens, start off with the numeric limits. It ended up being a little more complicated than I thought it was going to be. So start off with the maximum. If r parens is less than min parens, now we're going to update r parens, or min parens. And we're going to update our return vector. So this is going to be so it's less than, then we update. If it's equal, then we're going to push back. And then we're going to build the string. That's the thing. We need to build that string. We're actually going to clear this vector, which is kind of peculiar. I think we can do that. cppref vector. Can we clear? I think we can. I think it's possible. Yep, that works. So, yeah. So if we see something smaller, we're going to update the minimum parentheses and clear. And then if we don't see something smaller, but we see something of the same minimal size, then we push back. Now here's the tricky thing. We have to generate the array. Create string. Generate string. So the way we generate this string, now maybe we can generate this string with, while we're testing the subset. Can we do that? No, I don't think so. So string t is empty string 0 j equals 0. I is less than s dot size, increment I. And we're going to say if I is equal to bit to index of j, now we increment j, and say t plus equals otherwise t plus equals s of I. If I is bit to index, then we increment j the next index, and we say t of end bit to index, and this particular bit is set to true, which is part of, this is for I here, so we could do A and B instead of I and J. We also need this particular bit to be set to true. Oh, this is so tricky. This is such a tricky thing. bit to debug here too. How are we doing? 40 minutes? Oh boy. Oh boy. Okay. The race is on. Bit to index. The tricky part here is that we need to know that this bit is set in the first place. Which, oops. And that, actually that's fine. Or bit starts off at 1. Oh yeah, no, that's fine. Bit and I. Increment B and bit shift the bit to the left by 1. And then you push this back, the result T. Regenerate this string. And at the end of this, we're going to return ret. So that's rather complicated. Rather complicated. But I think it works. Let's see how it goes. Maybe it works. Wrong answer. Excuse me? What? Go right to left. We should get 1. Oh, excuse me. That's wrong. Well, first thing, this should all be just always give 0, but this is if count is less than 0. Then we set ret equal to false. That was my mistake. Okay. What is going on? What is going on? Oh boy, there's a lot of code to debug here. So every time T is just this. 1, 2, 3, 4, 5, 6 times. Shouldn't these be placed in there 6 times? Interesting. Okay. So, let's see, valid parens. And what integer did we get? With the bit count too. Alrighty. What do we get here? I is 0, bit count 0. So these are all valid parentheses. So that's false, right? No. If you have no parentheses. Yeah, actually that is valid, I'm sorry. Yeah, you could remove all the parentheses. And then this difference So that's interesting. So we added everything, all the parentheses. If you remove all the parentheses, then all parentheses less than min parentheses all parentheses, clear. These are equal. We generate a string t. How does that work? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is driving me crazy, brother. How long do I need to wait? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ugh. It's frustrating. So yeah, this is now, no, this is incorrect. So, okay, that's interesting. Oh, this is, I didn't realize I didn't put anything here. Oops. But still, now what's interesting is we actually don't do it this way. If this is the case, then we actually have a second if statement here, so this is slightly incorrect. Then we do these things. Otherwise we exclude it altogether. So if there's a bit there, I think it's the other way around. I think it's this one. If we are controlled by the bit index, then we check whether the bit's there and add it. Otherwise we take S of A. Yeah, this should be a little bit different, these strings. So these are totally different. Now, these are actually corresponding, so these are actually going to be, these should be left to right, not right to left. But that just means that this part needs to go left to right. Oh, that's so confusing. Oh, alright, so there's some issues of like numbers going right to left and strings going left to right. We'll come back to that, but that doesn't really matter here. Because this really should be... Excuse me, actually maybe it matters in both cases. Oh, that's obnoxious. Oh no. Thought that might cause problems. How are we doing on time? It's 10 minutes, okay. Alrighty. So you read from left to right. I is still going to be... So this is actually going to be from left to right, meaning I is actually going to start out, or X is going to start out as, we're going to bit shift it to the right. We're going to start out X at 1 bit shift to the left per parens minus 1 times, if you can imagine that. Yeah. And then x is going to be a bit shift to the right, 1. So if you have 5 parentheses, 0, 1, 2, 3, 4, your 1, if you bit shift it over 4 times, so 1, 2, 3, 4, start at position 1, add 4, now it's at position 5. 0, 1, 2, 3, 4, yeah, that's correct, yeah. Something more like this, and actually this is going to be opening parentheses now. 1, 2, 3, 4, 5, 6. Now I can't get over why what's being printed doesn't look right. I don't know what's going on there. Okay, it's a little bit better. We're a lot closer. We at least got this one. But these aren't correct. Also, the representation itself is wrong. Right, if we removed all the parentheses, it should just be an empty string. Oh, I did this wrong. You're going to update the bit anyway. I think that's the issue. The way this works, you have to move it. Yeah, there we go. Okay, I have to move to the right anyway. Okay. So this one's wrong, right? So what happened? Well, this should just go to false. What is going on? What? Just gonna use 20. So bit count is 2, remove 5 parentheses, remove 5. So somehow this one is okay. Remove 3 parentheses. So the 4 parentheses we have are these ones. 1, 1. Excuse me. 1, 2, 3, 4 here. So 1, 1, 0, 1, 1. Okay. So the opening parentheses, bit to index of I. Okay. Maybe this is wrong. I'll call that one I prime just to make it make a little more sense. I think that's wrong. Sorry, what? No. Yeah, it's probably takes a little bit of time to debug. I6. Wait a minute, what? That bit. Oh yeah, this doesn't match, does it? Well, no, that's fine. It goes left to right. And then it's this the bit map itself. That's okay. I'm a little confused. So I is 6. Whoa. When we get this mess over here, we get this. I have 2, bit index is 2. 3, 3, 4, 4, 6, 6. Oh, there's a lot going on there. What about this one? So before this one occurs, that's this one above here. Some variation of these things. So yeah, all of these bits have a bit index, so we shouldn't be too concerned. Pretty much everything, we're not going to even bother with extra character strings at all. This should just be a one-to-one mapping for the most part. So how did we end up with, this string? Oh, because, I think I see. This should be true at every instance. 11011. So this should return false. This part. I think that's the issue. This is working correctly to give you this, or not this one, but well, even this one, I guess. 1011. Yeah, these should be returning false though. So red starts out at true. we take this character. If it's an opening parentheses, we add 1. If it's a closing parentheses, we decrement. And if the count is less than 0, we set the ret to false. Ret and the count equals 0 is false. This just shouldn't return true. Why is that happening? This one, 11011. We have, I is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6. So really this one gets skipped. That's 2, 3, 4, 5, 6. So you get 1 there, 0, 1, 1. That's wrong. That's wrong. That is a correct. So the R parentheses is correct there. But what I'm being presented with here is not correct. I see the problem. This is also supposed to go the other way around. This is all supposed to start off at upper and upper 2 or something. Upper shift 1. Yeah. That's the mistake. That's my mistake. Okay. There we go. That's what it's supposed to show. But now why are we incorrect? We got this one. We got this one. Oh, but we got extras. Oh, I see. Multiple ways to get the same string. I guess we could just put this into a set instead. Instead of a wow, man, that's so complicated. It works, but it's complicated. Yeah, we could use a set. It's fine. Okay, I think this works. The question is whether or not it's too slow. And this might not work for more complicated test cases, by the way. Didn't even test the ones that have alphabetical characters in there. Oh no. Uh-oh. Okay, which one's causing issues? It's probably the second one. It's most likely the second one. Yeah, I think it's the second one. I think it is. But why is the question? Yeah, this bit to end. Oh. Okay, we didn't get a runtime error this time. That's interesting. This bit to index idea doesn't seem to work as well as it should. Oh boy. And sometimes it gives us a runtime error, which is strange. This should always always be set to something. So what's happening? So I guess I have to go add back all of our debug statements. Oh no. Okay. Alrighty, what happens if we do this? Does it still compile? Oh, we're way over an hour now. Okay, so now we have all that debug information again. Alright, so one of these has, is it missing a parentheses? Now my question is this because we're printing it incorrectly or something else? So if we're not including this parentheses, then we don't include that character at all. And we increment A. If it's not a parentheses, then we always include that character. But something must be going wrong with our bit to index values. So let's take a look at one of these, just an example, see if we have it correct. One of the ones that passed. So this is wrong, right? The bit count is 0. We remove 7 parentheses. It should be everything. 1, 2, 3, 4, 5, 6, 7. Yeah, so that should remove all the parentheses, including the one at the end. So what's interesting is we actually we increment both A and B when we're not that bit. When we're past, what's bit index though on this part? Excuse me. I think we should put these inside here, just to make sure we're not confusing things. Oh boy. Yeah, okay, so that is, so they should just be A. Upper shift 1. Bit and I. So this would just be false every time. But in some cases, we're going to update bit to index of B. Excuse me. We're never gonna get any parentheses here, but somehow we got a parentheses. It must have been S of A. Let's say which index was that? Oh, it's I, not A. Oh well, but I have so many typos. I don't see them, they just hide in plain sight. What about the other ones? Okay. That is really annoying. It's extremely irritating. Oh, the other ones are just all wrong too. Look at that. Whoa. Oh, what happened? What happened? Oh no. Oh no. Alright, we could probably go back to the original one. Oh no. Oh no. Okay, so somehow we ended up with this getting printed. What index are we on when this gets printed? And does this get printed? No, so this is actually coming from over here. Somehow bit and A ends up being not 0. And it's not B, it's, oh, it is I. No, I'm sorry. I did get that right the first time. Oh man, I'm confusing myself so much. Oh, it is I. That lets us, no, I had it right the first time. Confusing myself so much. Yeah, no, I is correct because I is referring to this sequence here. And you're checking the bit against I there. Something weird's going on in the second use case, or its test case. Something I'm not expecting and not realizing, not picking up. So yeah, we get this A, so test 7, okay. So when A is 7, somehow we do end up down here. 0, 1, 2, 3, 4, 5, 6, 7. So it should happen, yeah, it happens here correctly. And then at some point you get past now that's really weird. What is going on? 0, 1, 2, 3, 4, 5, 6, 7. So I think one of the issues is, yeah, A skips over the parentheses. It does. And then it's equal to a parentheses, equal. What is these two values here? What are these two values? Okay, what does this give us? Runtime error, okay. Oh, no kidding, it'd be a 6. Bit to index 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. There should be a bit to index for 6. Why isn't there one? Oh. That might explain some things. But, oh. Actually, you don't need to go further than that. That might have something to do with it. Typos everywhere, man. Typos, typos, typos everywhere. I don't know what to do about that. It just, I guess it just comes with, after more you program, the more you just kind of do these things naturally, do it correctly naturally. So I've got to make sure that this index, what do you mean I attempted to run it too soon? Excuse me. Excuse me. There we go, okay. Now the question is, if I put 20 in there, what's it gonna look like? The next question is, yeah, so I had the right idea. Just have to be careful how you choose your indices and how you stop them, break them. I don't really know how to, I guess you just double check that after you write the loop. Just say, hey, what was my ending conditions? Do I have my variables set up correctly with the right ending conditions? Because I mixed those up and it was hard to check that. I think I have a correct answer. It took a really long time to code. I had a lot of errors. Another error was the, there was two errors, that one, and the other one was over here with getting this logic correct. That took some time. Yeah, to get the right, I had to use the set. Need to use the set. Let's try to see, like, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, see how this goes. If it's TLEs, oh, it didn't TLE, that's fine. And we can add some characters. Add 1, 2, 3, 4, 5 characters in there. I think we're okay. I think we got it. Nice. Let's add a few more of these. Oops. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, something like this. Let's see how we do. See if we TLE. Okay, I think we'll TLE on the test cases potentially. I don't know what's gonna happen. We're kind of slow overall. We're pretty slow. We could try it, see how it goes. Also didn't test certain edge cases, I forgot. Forgot certain edge cases. I totally forgot to do that. These problems are so hard. I always forget something. I was so excited. I just did it. Runtime error. Runtime error. Oh, I see. Okay. Huh. You could just add 1 to this. I think that's fine. Shift to exponent -1 is negative. we can do. Just call this an edge case and be done with it. If you're less than or equal to 0, then you're just going to return a vector of strings with one string in it. And that's S. I think that's it. What are some other weird cases they have here? I'm so annoyed I got it wrong. I'm so annoyed. It might still be too slow, by the way. So we could have no parentheses in there. And we can have a whole bunch of characters and a couple of parentheses. And then there's always going to be at least one character. I don't know. Let's see. Oh, we did get a runtime error. Oh, no kidding. Whoa. Wasn't expecting that. Okay. Why is that? So which one of these caused it? It's gotta be one of the ones above. I think the ones below are fine. Yeah. Alright, is it the one above or the one below? Oh, okay, the one below causes an issue. And what about the one above? Do they both cause issues? No, the one above is fine. But the one below, for one reason that is not obvious to me, causes issues. Is it a logical issue? Index 4 out of bounds for type int parens. Undefined. 77, huh? Huh. There's only 4 parameters, friends, so B is incremented. Oh, well that's interesting. Ah, yeah, you just say, and B is less than friends. Yeah. That's a subtle thing. Could probably remove that, by the way. It's important to test your code, man. It's important to test your code. Subtle bugs and errors and things you forgot to consider will rear their ugly heads. Alright, we're gonna go for it. There's possibly some other tests that I missed, but we're just gonna go for it. Check it out and see what. Nope, we got it. Hey. Alright, that took forever. Took almost an hour and a half, and that was a pretty ugly brute force solution. There's another one of those questions. It's just another brute force solution. Like, I'm sure the discussion will be interesting, but like, you know, it's just brute force. Like, what do you want? Now, actually, there might be a much more clever way of doing this that I don't realize. That has to do with, like, you don't necessarily need to brute force this. That could be true. I don't know. I'm kind of pooped after that, you know. And also, I think in my mind, it seemed like it would be a much easier question to code the way that I wanted to code it. I mean, it's a relatively simple concept. It just has a lot of tricky pieces to it because you've got all of these like relational things going on. These mapping of indices to indices, and then that mapping has a certain bounds on it, and then has to be set up correctly, and there are the valid parentheses, and the string left to right is not the same as bit right to left, and just have to match that up correctly, and then you could have no parentheses, and that could cause issues, and got tricky things in the logic here. You want to get your bit count while you're checking whether it's a valid parentheses. There are so many pieces. I'm afraid to hit submit again too, because this could like randomly TLE the way that I did it. See, I'm afraid. I'm actually not afraid. Yeah, okay, we're fine. We're okay. We did really well in the memory, but I think we used constant memory. No, it's not constant memory. Actually, it's, wow, there's just not that much memory in the first place. There's not much to the string in the first place. But no, this is exponential time. Excuse me, exponential time algorithm. Right? You can see this upper is 2 raised to the power of the number of parentheses, and then we're actually O of n times 2 raised to the n, because each of these valid parentheses is n time. Yeah, I mean, we're looping through all the combinations of the parentheses. That's pretty simple. The only problem that we have is that it's a little complicated because of the extra characters littered in there, so we had to like really work around that, which is really annoying, but you can still do it. It's just programmatically makes things way more complicated, as you can see, because you got this extra bit to index mapping you've got to perform. It shouldn't really be that complicated, but for whatever reason it ended up being really complicated. Yeah, this is not too bad. This, I think, is the part that really got me, is that this piece, regenerating the string. You kind of have to go through this piece again. Now we can actually combine creating the string with this part and maybe speed things up, make it a little bit faster. But it's still, one, it's still pretty slow, and two, it's also still, you know, combinatorial time complexity, exponential time complexity. So yeah, it's one of those things. It's like kind of not worth going too deep into it, because like really the issue is just you need to be able to program it quickly. You need to be able to program it in 20-30 minutes rather than an hour and 15 minutes. Excuse me. But I think if I do this kind of thing a few more times, I'll get familiar enough where I'll be able to do it quickly. But yeah, ultimately it's one of those things where like, yeah, it might be interesting to look at the discussion. There might be like a better way to do this. Like, there might even be an algorithm, like some clever algorithm that's either like dynamic programming or recursive memoization or some other thing, but I don't see it. You know, I think it's probably kind of complicated, the other ways you might do this. It's small enough where you can manage with a brute force solution, so we'll just do that. I'm so disappointed with myself. I keep getting these wrong, submissions wrong. Oh man. 1, 2, 3, 4. We're gonna do one more. This is 80%. We're gonna go for like a little over 80%. And that'll be it for me. Yeah, that'll be it for me. All right. Thank you again for watching. I'll talk to you soon. Have a good rest of your day. Rest of your night. I think I'm gonna go to bed after this, or just kind of hang out, go to sleep. It's a lot to do these problems. It kind of takes a lot out of me. But yeah, thank you again. Take care. Have a good rest of your night.